solving a linear system of equations algebraically, the elimination method. Graphs of two linear equations are shown. 2x minus 3y equals 4 and 4x plus 3y equals 26. Label each line with its corresponding equation. And, alright, let's see. If y is 0, this will have an x-intercept of 2. So, better get a pen out here. So an x-intercept of 2. This is 2x minus 3y equals 4. And what will this have? Well, we'll have a y-intercept of a little over 8. So yeah, that's true. So 4x plus 3y equals 26. And just adding some arrows, which we can't easily draw on these lines. What is the solution of the system? Well, it's the point of intersection, which is 5, 2. Same system is shown below. Now, if you add all the terms from the lower equation to the upper, remember we can only add like terms, so we keep our x's and our y's and our numbers lined up. We get 6x and 0y and 30. Well, if 6x is 30, then x is 5, and that's the x-coordinate of the solution. Since you have an equation involving only the x variable, solve the resulting equation for x. We did, and the x-coordinate of the solution is 5. Algebraically determine the y-coordinate of the solution by substituting the x value into either equation, just like substitution. And actually, when we're solving algebraically, once we have one variable, that's how we get the other variable we substitute in. So let's go into 2x minus 3y equals 4, because it's got smaller numbers. And we say that x is 5, minus 3y equals 4. 10 minus 3y equals 4. Negative 3y is negative 6, and y is 2. And the solution of the system is 5, 2. And did you get the same answer? Yes, we did. The same system of equations is shown again below. Multiply every term in the first equation by 2. Okay, every term, there's 3 terms here, right? So that's going to be 4x minus 6y equals 8. And then rewrite both equations. So 4x plus 3y equals 26. Subtract the terms in the lower. So 4x minus 4x is 0x. Negative 6x minus 3y is negative 9y. And 8 minus 26 is negative 18. And you notice we only have an equation in y, which if we solve, we get y equals 2, which is the solution to the the y-coordinate. So, whoops. Well, I guess I'll write that in. So, what do you notice? We have an equation only in y. And when solved for y, we get the y-coordinate of the solution. Solution, period. Alright, and we've done this, and we've done that, and if you determine the x-coordinate by substituting into either, well, let's go with 4x plus 3y equals 26. So 4x plus 3y equals 26. 4x plus 3 times 2 is 26. 4x plus 6 is 26. 4x is 20, and x is 5, and the solution is 5, 2, and yes, we did get the same result. In general, the coordinates for the solution of a system of equations can be found algebraically by eliminating one unknown variable and then solving for the remaining unknown variable. This can be done by adding or subtracting the terms of one equation to or from, adding to or subtracting from the other equation. Why would the elimination method for solving this system be preferred to substitution? So if you look, we don't have a variable that we can easily solve. Right? We don't have a variable with a coefficient of 1. So it's not easy to solve for x or to solve for y, right? And we'd end up with fractions and woo, that would just be ugly. And why would elimination work? Well, when we add the two equations, since the y values have the same coefficient, then and their opposite signs, they can be added to eliminate the y. Elimination method. Step 1. If necessary, rearrange the equation so that the like terms in both equations are in the same position and in the same, I don't know, what's a good word here, in the same place with reference to the equal sign, i.e. the like terms must be arranged vertically. Let's go with arranged. I don't think these are necessarily the best words here, but they'll have to fit. It may be necessary to multiply one or both of the equations by values so that the coefficients of either the x or the y for the like terms are the same in both equations. Either add or subtract the like terms of one equation to add to or subtract from the other equation and thereby eliminate one variable. Okay, so either the x or the y is going to disappear. We're going to solve the resulting equation for the unknown variable that remains. Use one of the two equations from the beginning and the value found in step 4 to find the value of the other eliminated unknown variable, just like substitution method. Okay, so in other words, once we solve for one of the variables, then both methods become the same. Write the solution for the system of equations as an ordered pair and verify the solution in both of the original equations. Okay, let's do some. So here we have a choice, right? We could eliminate either the x's, and if we do, we're going to have to multiply this equation by 3, or we can eliminate the y's, and if we do, we're going to multiply this equation by 3. So I'm going to number these. Now here's the thing, if you like to add, you can multiply this equation by -3, making this -6. So some people like to do that. And if you subtract, they need to be the same. So what I'm going to do, I'm going to go with 2x minus 3y is equal to -19. That's equation 1. I'm going to multiply equation 2. So I'm going to say 3 times equation 2 is 18x minus 3y is -99. Now, if they're both the same sign, then we subtract. Okay, so 2x minus 18x, might have been better to go the other way, but -16x. -3y, -3 minus -3 is -3 plus 3, which is 0. And -19 plus 99 is 80. So x is -5, right? 80 divided by 16 is 5. Now we solve for x. We go back to one of the originals. Don't go back to a multiplied equation. Go back to the originals. So let's go with number 2. So at this point we substitute negative 5 for x in equation 2. Let's scroll down a little. So 6 times negative 5 minus y is negative 33. Negative 30 minus y is negative 33. Whoops. Negative y is negative 3, so y is equal to 3. And the solution is negative 5, 3. Which we then want to verify, right? So what do we got? 2x minus 3y equals negative 19. 2x minus 3y is negative 19. 2 times negative 5 minus 3 times 3 is that, put the question mark over, negative 19. Negative 10 minus 9 is that negative 19. Negative 19 is negative 19. So that checks. And 6x minus y equals negative 33. The left side is 6x minus y. The right side is negative 33. 6 times negative 5 minus 3 is negative 30 minus 3 is negative 33. Left side and right side are the same. Check. Works. Done. Solved. Okay, what are we going to do here? Well, first we have to rearrange this. Okay, so this will become 3x plus 4y equals 5, and this will be x minus 4y equals 3. And seeing as the coefficients of the y's are the same and their opposite signs, we're going to add. So 4x plus 4y minus 4y is 0. 4x equals 8, x equals 2. We're going to substitute 2 for x in, doesn't matter, so I say equation 1. So 3 times 2 plus 4y equals 5. 6 plus 4y equals 5. 4y is negative 1, and y is negative 1/4. So the solution is 2 and negative 1/4. Okay, let's check that. Need some space here and here. So 3x plus 4y equals 5. 3 times 2 plus 4 times negative 1/4 is that 5, right? 6, okay, 4's cancel, so 6 minus 1 is that 5. 5 is 5. Check. And x minus 3 is equal to 4y. 2 minus 3 is that equal to 4 times negative 1 is that equal to, well, negative 1, yes it is, check. And so that works. Okay, and you know, if you have time on a test, you could verify these graphically as well. Okay, so here's the thing, if we want to get rid of the a's, we would have to get this to be a 6 and this to be a 6, which means multiplying both equations. If I multiply equation 1 by 3, so 3 times equation 1 gives me 9a plus 6b equals 75. And very important thing is make sure you're multiplying all three terms. And equation 2 can just stay the same. And we now have the same coefficient. With opposite signs we add, so 11a equals, okay, this is 0, 88. So a is equal to 8. Substitute 8 for a in, let's go with 1. 3 times 8 plus 2b is 25. 24 plus 2b is 25. 2b is 1 and b is 1/2. When you're listing the solution, go in alphabetical order, 8 and 1/2 for b. We're going to squeeze the verification in here, so 3a plus 2b equals 25. 3 times 8 plus 2 times 1/2. Is that 25? 24 plus 1 is that 25? And 25 is 25. And let's get oriented on the tablet here. 2a minus 6b is 13. 2 times 8 minus 6 times 1/2. Is that 13? 16 minus 3, is that 13? And 13 is 13. So yes, it is. Check. And this is the solution to the system. Okay, step 1. So I always like to write it in x, y, so actually standard form, right? 5x plus 2y equals 7. 3x plus 5y equals 27, right? So when we rearrange this, it becomes positive 3x, the 5y stays, the 27 moves over, becomes positive. I've lined up my x's and my y's. And we can see I can't just multiply one of these equations. I'm still going to call this 1 and 2. So either we multiply through by 3 and multiply this by 5 and subtract, or we multiply this by 5 and this by 2 and then subtract. So you know what? Since that's going to be bigger, I'm going to go 5 times equation 2. 15x plus 25y is equal to 135. And I'm going to go 3 times equation 1. 15x plus 10y, right? And I'm subtracting. Remember, math is like chess. You're looking ahead a move. Equals 21. Subtracting, those are gone. That gives me 15y is equal to 494. Oh, seriously, at this point I begin to wonder if I've made a mistake, but I'm just going to quickly go through. And 3x plus 5y is 27. 5 times that's 15, that's 25, that's 135, yeah, 3, that's 15. Oops, that's 6y. And 21. Okay, so 25 minus 6 is 19. So does 94 divide by... Nope, well, that's almost as bad. Okay, so y is 94 over 19. Now, here's the thing. There is something else you can do here. Instead of plugging 94 over 19 into here, we can simply solve by elimination again. And so what I'm going to do this time is we'll eliminate the y's, and in order to do that we're going to multiply 1 by 5 and 2 by 2, so it's going to be 2 times 2. Hang on, let me move on the tablet here. 2 times 2, so that's 6x plus 10y equals 54, and 5 times 1 is 25x plus 10y equals 35. This will be negative 19x equals 54 minus 35. What is that? 21? No, 19. 54 minus 35. Whoops. 54 minus other minus 19. Oh, 19. So x is negative 1. And 94 over 19. Wow, is that true? Well, let's put a negative 1 in here and just see what happens. So, what would that be? 5y minus 27 is equal to 3. 5y is 30. Y is 6. What's 6 times? Is that a 19? 25 minus 6. $114. Yeah, I could do math. That's 114. 114. Which is 6. Negative 1, 6. Okay, well, I'm just going to leave this little mess up in here because, hey, that's the way stuff happens. And what it showed you, though, is that an alternative, if you got a kind of weird number there, an alternative method of solving for the other variables, just simply to run elimination again. And it would have turned out, had I eliminated the y's, I would have been better off because I would not have made that mistake. But I think things are negative 1, 6, so 5x is negative 2y plus 7. The left side is 5x. Right side is negative 2y plus 7. So what do we say? So negative 5. Negative 2 times 6. Negative 12 plus 7. Negative 5. So that's true. Let's clean the edge up there a little. And the other equation, 5y minus 27 equals 5y minus 27. And you can listen to the chorus. So 5 times 6 minus 27. 3. 3. And this does check. Which of the systems from number 3 could easily be solved using the substitution method? Anything where a variable is by itself, which is none of those. So actually this one, so A or B. So either A or B, because you have a variable by itself. So A or B. At a particular hot dog stand, Janet bought 5 drinks and 12 hot dogs for $26. At the same hot dog stand, Carl bought 3 drinks and 8 hot dogs for $17. Algebraically determine cost of a hot dog and a drink, assuming all the drinks are the same price, etc. Alright, so we need to determine the cost of a hot dog. So let H be the cost of a hot dog. So generally what's asked for in the last sentence is what becomes your variables. Let D be the cost of a drink. Okay, so step 1 in solving a word problem is to identify your variables. Step 2, write equations. 5 drinks. So 5 times the cost of a drink plus 12 times the cost of a hot dog is 26. 3 drinks 8 hot dogs is 17. Okay, here's my two equations. Now this does not solve by substitution very easily because we do not have a d or an h by itself. We could go for 24, so multiply this by 2 and this by 3. Let's call this equation 1, call this equation 2. Let's do that. So we'll go 2 times equation 1. 10d plus 24h is equal to 52. And we're going to multiply this by 3, so 3 times 2. 9d plus 24h is equal to 51. So d, 10d minus 9d is 1d. d equals 1. So it costs $1 for a drink. 9 drink. Times 2, 9d, 24, 17 times 3 is 51, 10d, 24. Yeah, d equals 1, so okay, then where do we go into, let's go to 1, so 5 times 1 plus 12h is 26, 12h is 21, h is 21 over 12. They're supposed to result by 3, right? So 7 quarters. So $3 and $1 and 3 quarters, $1.75. Okay, so a drink costs $1. And a hot dog is $1.75. Okay, now when I go to verify this, I am going to do it off the original. So 5 drinks, 5, I don't need to go times 1, right? 5 plus 12 times 1.75 is 26. Yep. And 3 drinks, 3 plus 8 times 1.75 is 17. So that works, right? So we go back, I go back, in a word problem, go back to the original. I don't really state the answer as an ordered pair, right? We need the answer in words. So there are the words, and then take the words, go back to the original problem, and see if the words fit the problem. And did you hear about? I didn't either, so we're done.